Today, we are going to talk about binary addition, which, as you probably guessed, is the addition of binary numbers. You can complete binary addition without converting the numbers into denary, although it would be a good idea to convert them at the end to check your answer. There are 5 rules that you have to remember when completing binary addition, which are 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, 1 plus 1 is equal to 10, and 1 plus 1 plus 1 is equal to 11. If you're wondering why 1 plus 1 is equal to 10, it's because the binary number 10 is equal to 2 in denary, and you can check this by writing out the binary column headings and making the number 2, and as you can see, it is 10 in binary. The same logic applies to why 3 ones added together is 11. The binary number 11 is 3 in denary. Now let's do a question from a past year paper to consolidate our understanding. 2 8-bit binary numbers are given. Add the 2 8-bit binary numbers using binary addition and give your answer in binary and show all you're working. This is a pretty standard binary addition question, and by show all you're working, what they mean is that they want you to show your understanding of all the rules, which I'll put over here. So what you have to do is that you have to work from the rightmost column towards the leftmost column, like how you do when you add denary numbers together. So over here in the rightmost column, we have 1 plus 1, which is equal to 10. However, 10 is a 2-digit number, and you can't put a 2-digit number when the space in this column is only reserved for one number. So what we're going to do is that we're going to put the 0 into this space, and the 1 becomes a carry digit. So we're going to put it at the top of the next column. Now in the second rightmost column, we have 1 plus 0, which is 1. However, we also need to take into consideration the carry digit, which is 1. So in this case, you have to add 1 plus 1 together, which is, again, 10. So you put the 0 over here, and the 1 becomes the carry digit for the next column. So now for this one, we have 0 plus 0, which is equal to 0. And then when you add the carry, it becomes 1. So we just write 1 over here. And you just continue this process until you reach the leftmost column. So here's the answer that we got. And what we can do in the exam, if we have time, is to check our answer by converting the numbers into denary. The topmost number is equal to 51, and then the second number is equal to 97. And our answer is equal to 148, which is correct because 51 plus 97 is 148. And in this way, we know that our answer is correct. And here's the mark scheme if you want to take a look at it. Now, the final thing we are going to talk about in this video is overflow errors. Sometimes when adding 2 binary numbers together, we can end up with an answer that exceeds our register size. For example, let's say we want to add 255 and 1 in binary. On the right side, we have 1 plus 1, which is 10, so the carry digit will go to the next column. And then here we have 1 plus 1 again, which is 10, so we have a carry digit again. And as you can see, this repeats until the leftmost column, where we will write 10 again. And the answer is 9 digits. But if our register size is 8 digits, one of these 2 things might happen. Either the program might crash, or the CPU could just drop the overflow digit since it can't store it anywhere. However, by ignoring this extra digit on the left, this would cause an unexpected result. In this case, the computer would think that 255 plus 1 is 0, and this is a problem because this is obviously not correct. So in the exam, you are expected to recognize this and write down the name of this error. Here's an example from a past year paper. After solving this, we can see that the answer is 9 digits. So over here, I'll write down that an overflow error has occurred. And as you can see from the mark scheme, you will get a mark for identifying this. If you want, you can pause the video here and try this past year question yourself. I'll show the mark scheme in 5 seconds. Anyway, that's it for how to add 2 binary numbers together, specifically 2 positive 8-bit binary numbers. Please leave any questions that you have in the comments, and thank you for watching!